Hello, welcome to Math 1324. This is Chapter 10, Section 3, Example 2. And in this example, we want to select the graph of y equals negative x cubed minus 3x squared plus x plus 12 using the end behavior of the function. This is pretty much exactly what we just did, so I'm going to go ahead and talk about the power function. I'm going to label the power function as PF. The power function in this case is y equals negative x cubed. So looking at this, the degree here is the exponent. In other words, it's the highest degree of the polynomial function. So the degree is 3. Notice that 3 is odd, and odd means opposite. And so what that tells me is I have two different possibilities. That or that. Notice that the leading coefficient here is -1. Specifically, it's negative, and that's the important thing. So what that tells me is that it is the second of these two. That's telling me that as this function goes to the left, it's going up, and as it goes to the right, it's going down. And you can just pretty much choose the function that will look like that. I do want to go ahead and show you this on the calculator so that you can kind of see what I would do. Could this be factored? Not easily. Okay, so I'll go ahead and show you what this looks like in the calculator. I'll see you there. Welcome to the calculator. I'm going to go ahead and go to y equals. I will type this in as negative x cubed, right arrow, and then minus 3x squared plus x plus 12. Awesome. And by the way, make sure that's a negative and not a minus sign. The calculator will give you, it'll throw an error whenever you put a minus sign there. Anyway, I'm going to press zoom 6 for the standard window. I'd just like to do that to kind of see what's happening. Notice I need to kind of move my window up a little bit to see what's happening up here. So if I press zoom, go to window, y maximum is what I want to look at. And let's make that 20. There we go. That's better. And here's what we're looking at. Notice that as we're going to the left, the function is going up. Now, technically, the function is decreasing there. But, looking towards the left, it's going up that way. But as you're going towards the right, it's going down towards negative infinity, which is exactly what we talked about for the end behavior. Now, if you have a function that's doing that or if you have two different choices where that's happening, where you go to the left, it's going up, and to the right, it's going down, you're going to want to look at your intercepts, starting with your y-intercept. Now, here, the y-intercept was 0, 12. That's what that point is there. And then you can kind of look at the x-intercepts. It's a little bit harder to see, but the y-intercept is usually the best. If you want to find your x-intercept here, do second calc 0, because those are called zeros. Go to the right, make sure you're just to the right of the 0, and notice that I'm above the x-axis here. Click enter, and then go right to where you are below the x-axis and click enter, and then click enter again. And so my 0 here is 1.706528. And the y is 0 because that's the definition of the 0. Alrighty, well, there you go. I'll see you in the next video. Have fun.